Hello again, this is Dan Qualley, April 8th, 2010, and what I've done is I've taken part of the motor off, armature, off of the motor part of my generator, place it with a small DC motor, and it's hooked up using a rubber band. So we're powering it with a 6-volt lead acid battery, and we've got my multimeter ready to go to show you the current, and turning on my speed indicator, have the lights ready to go. So let's get it going. Get it started. That's inertia. I want to break the rubber band starting at a dead stop. Good. Alright. So, first of all, drawing 0.31, 0.32 amps, and speed indicator says about 13, whatever that means. Lights, LEDs, about 200 LEDs. 2.5 volt nominal voltage, 20 milliamp nominal current apiece, and I'm going to see a little rubber band turning this generator. Get a shot of the rotors turning in there. Maybe a look at the coils. 18 gauge wire hooked up in series. There's 8 coils, 2 magnets, and again they're repelling each other. The fields between them are repelling each other. Right, not attraction, not north to south, but north to north or south to south, so that the rotors turn alternately, block one side or the other of each coil, causing the AC induction in the cores. Cores I'm using are hardware bolts, about 4-inch hardware bolts with either a 3/8 inch diameter. Not the best kind of cores to use. Ferrite would be much better to use here, but I didn't do it. I didn't use ferrite. Sorry. Anyway, it can be made a lot better than what it is. Let's put it that way. This is a very crude generator, but it's being turned by a very small motor and producing a pretty generous amount of current. I use LEDs to show the peak. Basically, you're seeing the peak current and voltages. I don't have a oscilloscope to show you the how the power output looks. Other people have done it. Had a replication from the Chinese, showed 5 watts in their similar size generator. I'm running this thing. That thing is currently measured the voltage on that. It's roughly 6 volts, and with the 0.3 amps, that's about 1.8 watts running this generator, which then powers these LEDs. Alright, so just want to show this thing being run by a small motor, and you can get an idea just how little torque that takes to turn this generator. Most of the torque is taken up overcoming the friction of the bearings. So that's enough for today's demonstration. Back it out, and thanks.